Well, good evening, everyone, and welcome to another edition of the RX Question Lab, where we are going to be tackling one of the most fascinating yet sometimes intimidating topics on step one, biostatistics. So here's the thing about biostats. At first glance, it might seem like a maze of p-values and confidence intervals, but once you understand the fundamental concepts, these questions can become some of the more straightforward points you'll learn on the exam. So we're going to work through questions designed to help you recognize patterns, identify key concepts, and of course, that systematic approach to USMLE questions. Once again, I am joined by Dr. Abraham Titus. Abraham, would you like to introduce yourself to the crowd?
Sure. So my name is Dr. Abraham Titus. I'm a hematology oncology fellow at the University of South Alabama. I've been an RX coach for quite a few years now and helped many students such as yourself achieve their goals on step 1, 2, and even step 3. I had to go over some high yield biostatistics concepts. It's one of those topics where, it's always, really tough to step in, just like how Jeff said, but really, especially for your step 1, it's going to be your free points that you kind of get and save you a lot of, it's the right answer when you parse it. It is something that you don't want to just memorize without understanding, because it is going to come back step 2, and it comes back very strong for step 3. So you have to be getting the concepts down as well. So excited to start off today.
For Question Lab, we like to cover topics that you're going to be faced with on the exam, but we're not just here to focus on content. We really also want to focus on technique. And as a part of this, we really want you to develop your own methodology for answering questions. We have a suggested, regimen which you can follow or which you can adapt. But the key thing is that I really want you to have, a methodical approach when you are in the Prometric Center or when you are getting ready to take your exam, so that you can really become an efficient answering machine. So as we go through this, you're going to learn a little bit about how we advise students to approach these questions. So with that, I do want to note we are going to have a raffle at the end of tonight's event, and one lucky audience member is going to receive a subscription to RX 360 Plus, which is the full USMLE-Rx suite. So make sure you stick around. You have to be here to win. We also have a special discount for those who are here. So once again, let's go ahead and get ready. And we're going to start with question number 1. Those of you who have been regulars know what I'm about to say next, but as we reveal this, you're going to see something's missing. And those are the answer choices. So when you encounter a new question, we encourage you to cover up the answer choices. And this is partly because we want you to focus. And sometimes you're going to see a distractor or a term, a concept, something that maybe you don't remember, something that's confused you, something that you've struggled with perhaps. So what we want you to do is really, take this in a really rigorous fashion. So we say cover up those answer choices. And then number 2, we want you to read the lead-in. And in a NBME style question, the lead-in is really the question here. So in this case, the lead-in is, according to these data, 95% of the sample population's values would lie between which of the following limits? Okay, so part of the reason we want you to read the lead-in is that, some of the vignettes on step 1 and step 2 CK are long and they're filled with a lot of information. Some of that information is useful. Some of it is just, there to perhaps distract you or just to give you more things to parse. So by reading the lead-in first, now you have a bit of a compass. You know what it is you're going to be looking for, or even what type of answer you would expect to see. as you go and read the vignette. So we've read the lead in. Now we're ready to take on the vignette. A study is conducted on a college campus to make students aware of the complications of high blood pressure. Volunteers report to the university physician's office to have their blood pressure taken electronically while they receive education materials on health promotion. There is no age requirement, but students are required to be enrolled in classes full-time. The blood pressures of 1,200 individuals are recorded and analyzed. The mean systolic pressure is determined to be 115 with a standard deviation of 10. The measurements taken demonstrate normal distribution. So once again, the question, according to these data, 95% of the sample population's values would lie between which of the following limits? Think about what type of range you might expect to see, or what that answer you would expect to see, as I pass it on to Abraham.
All right. So Jeff did mention some very important things, like the fact that there's no options that you see, and that you want to kind of think about what's happening, figure out, make sure you spend a lot of time reading the lead in before you kind of come up with your answer. So, there's a lot of important things on here. It's not as dense as some of the other questions we expect in your step one, but there are some key things we do need to pay attention to. So why don't we just go through, why don't we highlight some of these keywords here, and let's take a look at, what is really important. All right. So we know it's some kind of studies going on. We know it's about blood pressure. Okay. There's about 1,200 individuals that get their blood pressure analyzed. And you determine that the mean is 115. So that should have been highlighted. My bad. And the standard deviation should be 10. So there's a 115 is the average and the standard deviation is 10. So that's very important information that you get from here. And it is normal distribution. So when they say normal distribution, what do they mean? So that's a biostatistic term where you find that the Gaussian, the bell curve distribution. They'll describe it. And they want you to know 95% of these populations would be between which of the following limits. So they're going to give you a bunch of ranges. And you need to know 95% of these 1,200 patients or individuals will fall in which criteria. Okay. So in your mind, you should think, okay, 95%, what does that mean in terms of normal distribution? I'm going to talk about it a little bit, and hopefully we can get to a way how to make this as simple as possible, easy for you to remember, and something that sticks with you long term. But let's look at the options and let's try to figure out what would be the best answer in this situation. All right, so we got 5 options, classic for 1 questions. I had to start with option E and make my way to A, just because in case, typically I find that the distractors are always at the top, but there's no rhyme or reason for that. It's just something that I do personally. Option E, 95 to 130, the blood pressure. Option D, 85 to 145. Option C, 115 to 135. Option B, 115 to 125. Option A, 105 to 125. So there's a lot of numbers here. Can be a little overwhelming, but remember, the mean blood pressure is 115. And you can just, that's the most important point right there. And you want to look for where 95% of the patient population feels. So if you kind of understand what this question is getting at, it should be a relatively straightforward question. If you're not 100% sure what normal distribution means, what that 95% means, then this would be a tough question. So this is a learning concept. And we'll talk about how to break this question down and how to make this an easy, free question on your step 1. So take your time, think about this one as Jeff pulls up the poll.
Okay, everybody. So we have launched the poll. Once again, based on what you were seeing there, 95% of the sample population's values would lie between which of the following limits? Some of these questions are going to be tricky. And again, especially if you're something that it's been a while since you've dug into biostats, or maybe you really haven't gotten into it. The main thing for us is just to make sure that you're you're understanding the core concepts and understanding what it is that you're going to need to be able to calculate on test day. Let's see, about 2/3 of you have voted, so I'm going to give you just another few seconds, and then we will close the poll. Okay, everybody go ahead, take a shot. Okay, I'm going to close the poll, and let's share the results. So this is a 2-horse race. About half of you went with answer choice E, which was 95 to 135. And about a little over a third of you went with answer choice A, 105 to 125. So it's a smattering of votes for the other answer choices. So interesting. Let's go ahead and hide the results and reveal the answer. And the answer is indeed answer choice E, 95 to 135. Well done, everybody. If you didn't get it right, that's okay. That's why we're here. So Abraham is going to walk us through it. So Abraham, take it away.
Sure. Well, great job, guys. This was one that if you know the concept, it should be pretty straightforward, but it's something that it does take some practice to learn. There is a concept called Gaussian distribution, and we talk about how we separate the blood pressures. Okay, so you got to imagine that graph. I don't know if you guys have seen that typical graph before. You'll kind of see it break down by standard deviations, as you can see here. Perfect. So this is a very important graph to understand. So that top of that mountain there, that hill, that top, very top, is where my mean is going to sit. And that mean in this situation, what did they say the mean was? So they said the mean was 115. So that's going to be the middle. So you want to think about, okay, it's going to be plus and minus, and the standard deviation is 10. So if I say within one standard deviation, it would be plus 10 minus 10 of that. So for example, option A, a lot of you guys picked A. That is one standard deviation. So the question asks, where would 68% of the patients would fall under? You would say A, 105 to 125, which is one standard deviation up, one standard deviation down. And that would be option A. That would be kind of what most second most picked choice right there. But the question is asking 95%, which is two standard deviations. And you have to understand that you're going to go a little wider and you're going to add 20 up, 20 down. So which is 95, which is 20, which is 20 down from 115. And then if you add 20 up, it's 135. So that's option E. So that's why really you have to understand this concept, understand this graph, and understand that it's going to be 68, 95, 99. You want to always repeat that yourself. 68, 95, 99. And understand that 68, it's one standard deviation each side. And they can make it a little tricky. They can only ask about the upper side or the lower side. So you have to understand, that's 34%. And then you're adding on the total 95% there, which then you can split in half and do the 47.5 on each side. Or there's 99%, which is the 3 standard deviations. So in this situation, option A would be 1 standard deviation. Option choice E would be 2 standard deviations. Option choice D would be 3 standard deviations. And then B and C are tricky because they're going 115.2. So it's not going both ways. You're only doing a higher number. So you're not following the Gaussian distribution. So you would only do standard deviations upwards, which wouldn't fit with the 95%. And you would have to do a little more math for that. I think it's a little more complicated with calculating that. But this question is very simple. Just understand wherever the mean is, if they say 95, think 2 standard deviations. If they say 68, think 1 standard deviation. If it's 99, think 3 standard deviations. So memorize this chart, understand this concept of standard deviations, and this questions will be a freebie on exam day. Great job, guys.
Okay, good way to get started. And again, a nice little study tool. Think about this. You can screenshot this or watch it on our YouTube replay. But again, yeah, one of those things that you just want to commit to memory. Good. So we are off and running, and we are ready for question number 2. So one of our shortest questions. And again, we've covered up all the answer choices. and we're going to read the lead-in. So which of the following can best be determined in this type of study? So again, pretty clear, and you kind of know what it is that you're going to be looking for when you're reading through the vignette. So let's go ahead and do that. All adult inhabitants of a small city are eligible for participation in a study. Participants are contacted at a single time point and asked about their level of fruit consumption and whether they currently have colorectal cancer. Which of the following can best be determined in this type of study? See if you can narrow in on that as I pass it off to Abraham.
All right. So a different style of question. So it's not asking about, your distributions or trying to get you to think numbers, but different studies, right? This is another part of biostats, understanding kind of the different types between, multiple different studies we have out there. But there's some key points in here. It's short, but it's packed with information. So let's highlight some keywords here. Let's try to figure out what we're trying to figure out in this question. Okay. So we have this study that's going on. The question again, read the lead in. Determine in this type of study. So you want to know not just what study it is, what are you determining? And I think a very important thing here is single time point, right? So it's at one time, it's a snapshot. You could say that. Where I'm looking to see how much fruit and then comparing to colon cancer. That part isn't as important, but the most important part is the type of study. So if I can think about what kind of study this is based on the description, I should be able to think about, okay, what I'm determining from that. So each of the studies have their own special things. So one study leads to this, one study leads to this, one study leads to this. I'm going to talk about that when we talk about the answers, but I want you guys to think about that as well. All right, let's look at the options here. And this is a pretty straightforward. So let's go from E to A. So E, relative risk. D, prevalence. C, incidence. B, causation. A, attributable risk. They all have their own kind of unique features about it. And if you guys know the answer right away, try to think about what else these other things could be relating to and what tests would give us that answer. That's a kind of a thought exercise I always do. If I know a question is real easy and I can get it, but if it's not, then think about it. Try to make sense of what's going on in the situation. Think about what kind of study we're talking about and what would be determined using that study. Okay? These are classic questions on STEP. You want to make sure you lock these down. Take your time.
Okay. Well, we're going to go ahead and launch the poll. Let us know. Onto this list. What can best be determined in this type of study? One of the key things, we always really want you to think about is, what, in one of the benefits of Abraham helping to highlight things is that, there's going to be, really pivotal information included in the vignette. There's also going to be information that's, irrelevant or, kind of beside the point. It used to be that you would run across a question where you didn't even have to read the vignette. I think that might happen once in a blue moon on step one. It is really one of the reasons why, you want to read that lead in first, so that you have, kind of a framework. You have a way in, and you've got your sensors up, you've got your antennae up for information that's going to help you answer it. Okay, so let's see. About 3/4 of you have voted. And what I'm going to do is close the poll. We've got more people voting here. I'll just give you a few more seconds for those that were maybe hesitating or maybe trying to decide between two choices. Always go ahead and let it rip. Okay, so let's go ahead and share the results. And okay, interesting here. We've got almost half of you went with prevalence, answer choice D. And then kind of tight race in place between relative risk, incidence, and attributable risk votes for causation. So kind of a interesting pattern. So let's go ahead and hide the results and reveal the answer. And the answer is answer choice D, prevalence. So overall, we're doing pretty well tonight. That's excellent. But it's okay because over half of you didn't get it right. So we want to make sure that you get it right on test day. So Abraham is going to ensure that that is the case. Abraham.
All right. Great job, guys. Again, this is a classic biostats question. You want to be able to know the terminologies. I always tell my students, you don't need to be good at math to be good at biostats. You need to know terminology. You need to know what things mean and what they represent. So it's kind of more understanding the concepts behind the biostats and what the numbers represent as opposed to actually doing math and doing algebra, things like that. So let's break down what we're seeing here. First of all, I want you to kind of make a decision about what type of study this is. A single point in time. This is a snapshot in time. This is a cross-sectional study. Okay. I'm taking a survey at one time. What's happening? I'm not doing it over a long period of time. I'm not going back in time and checking in the past, or I'm not going in the future and doing it for the next year. I'm doing it at one single point. That is a cross-sectional study. Think about I'm cutting a tree in half and doing a cross-section of the tree. So I'm looking at that only one area. So that's the idea. Okay. So when I'm thinking cross-sectional, I'm not going to be able to find out how many new cases there are or what caused it or what's the risk of getting it. All I can tell you is how many people have colon cancer or how many people that are eating fruits have colon cancer or how many people that aren't eating fruits have colon cancer. So all I can tell you is how many. Okay. So that's what this comes down to, understanding terminology. So what do these different terminologies mean? So let's go through options here. So the answer here is prevalence, right? So prevalence means how prevalent is a disease? How many people have colon cancer? That's it. Because regardless, total cases is prevalence. What incidence? A lot of people picked incidence, actually. I thought, no, that was interesting. So incidence is new cases. So, if I do a cross-sectional study, I have no way of knowing, is that a recently diagnosed in the past month colon cancer or a year ago colon cancer? It's very variable, right? So incidence is new cases. I need to look kind of forward or back to kind of see, I'm trying to calculate incidence. I'm looking at new cases. Prevalence is total cases. Okay, what about these risk, guys? Attributable risk, relative risk. We hear these terms used thrown around a lot actually in biostats, and these are some important things to be aware of. Relative, always think divide. So I'm thinking the risk in exposed divided by the risk in unexposed. So it's all the division, it's a relative number. And it's going to be like, for example, I'll give you a very classic example I always give my students. So if the chance of getting lung cancer in a smoker is 20% and the chance of lung cancer in a non-smoker is 1%, the relative risk is 20 because the person who's smoker is 20 times more likely to get the lung cancer. So you do 20 divided by 1, 20. Easy. Attributable risk, on the other hand, is similar but different. Instead of division, but a subtraction. So instead of saying they're 20 times more likely to get lung cancer if they smoke, they say they're 19% higher to get cancer. So you're subtracting the percentages. So you're 20% minus 1%. So it's instead of how many times likely, it's how much percent more are they. So that's the kind of the way you can differentiate attributable risk. There's obviously when we talk about treatments, it flips it. It's relative risk reduction and attributable risk reduction, which kind of makes it also tricky, but it's just practice. Once you do some of these questions, it makes it real easy. And really that wouldn't be given any of that information with a cross-sectional study. You need much more information for that, such as a cohort. And then, and then causation here, again, you would not be able to get a causation based on just a cross-section. You need a randomized control study looking at, people that are not getting it and people that are getting fruits and then comparing the two. And that would become helping causation. But in this situation, very simple. It's a simple study. It's a survey. All you're going to get is prevalence. Good job, guys.
Okay, everybody. So great work. Quite a bit already. And we're halfway through. So we've reached our stretch break. So let's take a quick moment to catch our breath after those first biostats questions. If you're finding these concepts useful, just want to remind you that this is just a small sample of what USMLE-Rx offers. Our QMAX question bank has over 5,000 board style questions in there for step 1 and step 2 with strong coverage of biostats. Each question comes with detailed explanations that walk you through not just the right answer, but as Abraham's doing tonight, why the other options are incorrect. And this is crucial for mastering topics like study design and statistical significance. Part of what makes USMLE-Rx special is we have an integrated learning system, right? So we have RX Bricks, which are our interactive digital learning experiences that help kind of break down some of these complex topics into manageable, engaging modules. We've got all of our Express videos, over 1,300 of them, which offer explanations from med students, concepts that can be difficult to grasp from just text alone. And we also got flash facts, so quick, convenient ways to test your knowledge of things like formulas and statistical tests. So we also have, really rich performance analytics system that helps you identify which concepts you need to focus more on. Really helping to allow you study smarter, not just harder. So if you haven't tried USMLE-Rx yet, please head over to usmle-rx.com. We've got a free trial where you can test out everything. And we'll also have a special discount here at the end of tonight's event. Okay, great. So let us get back to business and head into the second half of tonight's event. Again, we're going to have a raffle here a little bit later on. And also, like I said, you do need to be here in order to win. And we'll have a special discount, some other offers. Okay. So, again, got a pretty concise question. So you see the numbers here. So we're going to have to put our brains in gear. So first off, obviously, we've covered up all the answer choices. Let's read the lead in. Which of the following best describes what would happen to the test sensitivity and specificity in the new population? Okay, obviously some important news there within the lead in, which we can take with us as we read the vignette. A screening test has a sensitivity of 70% and specificity of 80% when assessed in the general population. An investigator seeks to use this test in a population in which there is increased prevalence of the disease. So, which of the following best describes what would happen to the test sensitivity and specificity in the new population? So in your mind, you could be thinking about, what do you think would happen as I pass it over to Abraham?
All right, so we're switching gears again. We went from, looking at the Gaussian distribution to last question where we kind of looked at the different studies and what we tell us to, what would happen if we did increase. We're talking about sensitivity, specificity. We're talking about specific numbers, but in general, it's saying that, someone has increased prevalence. So let's highlight some keywords here. Really, this is another concept that I want you to just understand and really lock in because it's going to be repeated again and again in multiple different ways and however they ask this question. So let's go through, let's highlight some keywords here and let's kind of try to figure out what's going on in this situation. So again, look at the lead in. Best describes, so which of the following best describes what would happen to the test sensitivity and specificity in the new population. So it's not just what's happening, but in this new population. So what is a new population? So it tells you sensitivity 70%, specificity is 80. So not a bad test. And investigator seeks to test population, and there's an increased prevalence. So what do we say prevalence was last time? So prevalence is total people with the disease, right? So there's increased prevalence of the disease. So what would happen to the test's sensitivity and specificity? So you want to think, okay, is one going to go up, one going to go down, or both going to go down, both going to go up, but they going to change. So that's kind of the different options with it. I want you to already have an idea in mind before you even look at the options. Don't get too caught up with that. Just understanding this concept is very important. So let's look at the options. And I think even if you know the answer, I want you to think a little bit beyond this and think about, what about the other findings? What about, the predicted values? And we're going to talk about some of these things as well once we answer this question. So you have 5 options again. We'll start with option E here. Specificity would increase, sensitivity would decrease. Okay. Option D, specificity would increase without change to sensitivity. Option choice C, specificity would decrease without change to sensitivity. And option choice B, sensitivity would increase, specificity would decrease. And then option choice A, neither sensitivity nor specificity would increase. So is one affected, not the other? Are they both affected? Different ways of just kind of saying that. So you want to understand what would happen if I have more population. So the prevalence went up that have the disease. So take your time, think about this question, and let's try to pick the answer that makes the most sense for you guys. And even if you don't know it, still pick an answer, right? There's no penalty for picking for picking the wrong answer. You want to never skip an answer, even on testing.
Okay, you've listened to Abraham, so here we go. We're going to launch the poll, and you can tell us which of these answers best describes what would happen to the test sensitivity and specificity in the new population. Had a few questions asking us about the recording of tonight's episode, and that will be going up on our YouTube channel later this week. We actually have a question lab playlist. So going back to my comment earlier, I think this is tonight is episode 172. So anyway, if you wanted to, you could essentially binge for 170 hours of question lab just by going to our playlist. So again, you're getting ready for dedicated. Maybe you're thinking about ways to stay sharp. We've got tons of great insights in question lab, and always loaded with good helpful tips in how to crack the code for some of these questions. It's and I think that this is one of our, we haven't done biostats that often. We've gotten the record bit, so I'm really happy that all of you are able to join in tonight. Okay, let's see. We've gotten almost 3/4 of you voted. So Ed, and if you're hesitating between two choices, just close your eyes and pick one. We can go from there. Okay, so I am going to close the poll, and we're going to share the results. Okay, interesting breakdown here. We've gotten a little over a third of you were thinking the sensitivity would increase while specificity would decrease. And a little under a third of you thought that neither sensitivity nor specificity would change. But quite a few votes for answer choice D and answer choice E. So interesting. No clear winner here. So let's go ahead and hide the results and reveal the answer. And the answer to question 3 is answer choice A. Neither sensitivity nor specificity would change. So this was clearly a trickier question. This is often the case with Question Lab. It gets a little more difficult as the night goes on, but get it right, that's all right. Abraham is here to light the path. Abraham?
All right. Well, don't worry, guys, if you got this wrong. It is a little tricky, but once you get it, you get it. It's one of those things where, until you've gotten one of these questions wrong, and all of us have at one point, you won't really learn it. So you have to get it wrong to learn it. And this is one of those situations. So let's talk about this. Okay. So prevalence, like we said, prevalence is all about total people that have the condition. And the specificity and sensitivity of a test will tell me how good a test is at detecting the disease or screening out or screening in the disease. For example, sensitive tests are good screening tests, whereas specific tests are good confirmatory tests. That's a different talk. We'll leave that right there. my main focus here is going to be that prevalence has no effect on sensitivity or specificity. A test is only as sensitive and specific as the test is, regardless. So if the test is, let's say, like a 90% specific test, if I test 10 people, well, like 9 of the people will have, the correct answer, whereas one person won't. Whereas if I do 100, it'll still be 90 versus 10, right? That percentage is still staying the same. The sensitivity and specificity will not change regardless of the prevalence of the disease. So if I'm talking about a disease such as common as like the flu versus a test like for something like as rare as Ebola. So there are different spectrums to the situation, but regardless of how prevalent the disease is, neither sensitivity or specificity will change. Now, there is some key points important for here. What would change is predicted values. That's what I kind of mentioned when I was reading the question. There's something called positive predicted value, which is PPW, and negative predicted value, which is NPV, PPV. Now, what is the difference between sensitivity, specificity, and predicted values? Well, sensitivity, specificity is talking about how good the test actually is, regardless of the population. Just independent, it's how good is the test. The predicted values kind of matter a little bit. It's saying that, okay, I tested positive for flu during flu season, where everybody around me has flu. So that positive value has a higher meaning. So that positive predicted value will be higher. So what I remember is that positive predicted value is increased with prevalence, P and P. Prevalence means high positive predicted value. Is that if I test it in predicted values, I've already tested positive. So positive predicted value, I'm already positive. What are the chances I actually have flu? Negative predicted values, I tested negative. For example, I tested negative for Zika virus. Well, Zika virus is pretty not very common in the state I am in. So therefore, the negative predicted value will be really high for that because the prevalence is low. So remember, high prevalence, high positive predicted value. If the disease is very prevalent in the neighborhood and you test positive for it, it's likely that you have it. If the disease is not very prevalent and I test negative for it, it's likely I don't have it. So negative predicted value, low prevalence, high prevalence, positive predicted value goes up. Sensitivity, specificity is not affected. So that's a key differentiator between the two things. And also the formula will also come in there. I'm not going to go into the formula with this question, but you need to know your true positives, true negatives, false positive, false negatives, and kind of know how to place them in the formula. There's many ways, easy ways to remember it. I have my ways, and there are different ways as well. Look at first aid. Try to get a good grasp of how to simplify and understand the formulas. And don't just memorize the formulas, understand when to use them and why you're using them. That's what the trick is for biostats. But not a good job, guys, for the ones I got it right. If you did not, remember, sensitivity specificity does not get affected by prevalence. Take that away from this stuff.
Okay, there you go. Once some USMLE gold there for you to stash away so that you can definitely answer that question or similar question on test day. Okay, guys, we have reached the end of tonight's event. That means question number 4. You guys have done a really nice job tonight. We've gotten some great questions in the question box, and lots of questions about PPV and NPV down there. So appreciate all of the engagement, and we'll do our best to answer some of those questions. But let's go ahead and tackle our final question of the night. And again, pretty crisp vignette, and this is what I would consider a pretty long lead-in. So let's go ahead. We've got all those answer choices covered up as usual. So let's read the lead-in. Which of the following is the probability that 5 randomly selected non-smoking individuals exposed to secondhand smoke for more than 10 years will all develop lung cancer? Okay, so there you go. That's lots of things going on there within that lead-in. So understanding what it is you're going to be looking for, let's read the vignette. A researcher conducts a study on the occurrence of lung cancer in non-smoking subjects who reside with smokers. It's discovered that non-smoking individuals subjected to secondhand smoke at home for 10 years or more have a 50% chance of developing lung cancer. So, which of the following is the probability that 5 randomly selected non-smoking individuals exposed to secondhand smoke for more than 10 years will all develop lung cancer? If you already know, you can start thinking about that math right now as I turn it over to Abraham.
All right. So again, lots still questions from the last question. I'll answer it while I'm typing while I can, but very important in this question. Now, focus on this question. Try to understand what's going on here. So we have a little bit of a different situation. This does require a little bit of math, maybe. So let's think about what's happening here. So let's highlight some keywords. Let's talk about what is most important takeaway from this. Again, 5 randomly selected non-smoking individuals are exposed to secondhand smoking for more than 10 years. What are the chances that they all will develop lung cancer? So that's very important to understand. So they've been exposed. There's 5 of them, and they all need to develop lung cancer. And we're talking about probability, right? Probability is something you got to think back to high school. And that stuff's back right into your step 1. So you want to understand probability, understand how we calculate probability. And it is important in medicine to understand what are the chances. And then let's go to the top, right? So there's a researcher that was doing a study. We're looking at the occurrence of lung cancer. And we already know it's non-smokers with exposed to secondhand for more than 10 years. And they find that they have a 50% chance of developing lung cancer. This is definitely exaggerated for the question, but you want to understand just for simple numbers' sake. Okay, so we have a bunch of these patients, and each of them had 50% chance of developing lung cancer because of their risk factors, whatever it is. If 5 of them all develop lung cancer, what are the chances of that happening? And each of them have a 50% chance of developing lung cancer. So there's a little bit of math to do for you guys. Take your time, think about it, pull out your calculators if you need to, and let's try to figure this out. So let's pull up the option here and let's try to figure out how we would get to this answer. Yeah, this is often trips a lot of people up, and it's not as difficult as you may think it is. I want you to take your time, understand the concept that we're talking about. 5 random people, and what are the chances that they all get lung cancer if each of them have 50% chance of getting it? That's I said, it's another way to look at it. But same concept. You got to do some math here. Take your time, think about this, and let's give you a little time, focus on this one. Let's try to pop the questions up here.
Okay, everybody, I'm going to launch the poll here in just a moment. Hope you have locked in on the correct answer. I will note that that lead-in is so long that it broke our GoToWebinar, so it's cut off a little bit. So I'm going to go ahead and launch it now. So again, which of the following is the probability that 5 randomly selected non-smoking individuals exposed to secondhand smoke for more than 10 years will all develop lung cancer? Hopefully you were able to home in on an answer. And again, we know some of you are, trying to think back to your biostats days, or haven't really dug into this much. So again, Question Lab is all about learning, taking in as much information as we can so that we're ready for the next self-assessment or the next exam, and eventually the boards. Okay, well, let's see. We've got a little over half of you have voted. I think I know this is our toughest one of the night, so give you just a little bit more time. It's a great crowd here tonight, though. Really appreciate all of the kind words and all of the great questions that you've popped into the question box. I know a lot of you have stayed up pretty late and up pretty early, so well done. prioritizing your studies over sleep. You can't do that all the time, but we hope that it's been worth it. Okay, I'm going to go ahead and get ready to close the poll. Almost 3/4 of you voted. I like it to hit 75% before I hit that close poll button. So I just need a few more of you just to give it a rip. Let us know what do you think it is. And let's go ahead and I'm going to close it now. Okay, so let's share the results. So almost half of you went with answer choice B, 2.5%. Quarter of you went with answer choice C, 20%. Answer choice E, kind of a distant third with 3%, or with, 16%. And then answer choices A and D also got some votes. Okay, interesting. Let's go ahead and hide the results and reveal the answer. And the answer for the final question of tonight's Biostats question lab is answer choice E, 3%. So 16% of you got that one right. So definitely, we knew this was a tough one. Abraham, we're going to have to spend a little extra time walking through this one.
Yep, and I expected a lot of you guys to get this one right. So I put this one at the last one. It by itself is not a hard question if you know the trick. It's something that, we've learned back in the day, but we probably forgot over time. Whenever we think of a probability, the trick is multiplication. And when we do multiplication, it's into each other. Okay, so let's take this step by step, okay? Let's talk about 2 people, first of all. We have 5 people here just because it makes it tougher, but it's number 1. So each person has a 50% chance of developing lung cancer. So patient A has 50% chance, patient B has 50% chance. What are the chances they both develop lung cancer? Well, if I have 2 probabilities, I multiply them. So 0.5 times 0.5 would give me 0.25, right? So that would get me the chance of 2 of them developing lung cancer. So 25% would be the answer if I'm talking about 2 people. What about 3 people? Well, then there's multiply again. 0.25 times 0.5 again. That would give me 0.125. So that would make it 12.5% for all 3 people to get lung cancer. What about 4 people? Let's just keep adding them. Times 0.5. It would be 0.062, so which is 6.2%, 25%. And what about 5 people? Multiply that again by 0.5. You get 0.03125, which is 3%. That's it. It's as simple as that. You just multiply 0.5 5 times into itself. That's it, right? Or you can just do 0.5 to the power of 5. That's like kind of the more math way to do it, right? You're multiplying 0.5 into itself 5 times because each person has a 50% chance of developing lung cancer. There's no trick to the 2.5 and things like that. I know you guys are trying to figure that out or just jumping to the answer because it has 25 in it. So, 50% maybe there. Just take it step by step. If they say 4 people, then I'll do 0.5 times 0.5 times 0.5 times 0.5 4 times. This is 5 people, so you just do it 5 times. It's simple as that. You just keep multiplying it into the calculator, or you can just do 0.5 to the power of 5. You'll still get the same answer. And then it's a percentage, so you multiply that by 100. So if it's 0.03, it's 3%. Simple as that. No need to overcomplicate these kind of questions. They can give you a different situation where, a chance of somebody having hypertension is 50% and the chance of having diabetes is 60%. What are the chances someone has both? You literally just go 0.5 times 0.6, and that's the answer. When you think about probability, just keep it simple. Just multiply them into each other to get the total or the chance of having both. And since we're dealing with a percentage, it'll get a smaller number. I hope that makes sense. I don't want it overcomplicated by, getting into the nitty gritties of it, but this is as simple as it is. Just multiply 0.5 into itself 5 times. The other options will not be the right answer. And 3% would be the correct answer if you multiply 0.5 times 0.5 times 0.5 times 0.5. You guys have questions about that, you can definitely drop it in the question box. And these questions, sometimes it's tricky to do mental math. I saw someone said that they knew what they're doing, but they did the math wrong in their head. Use a calculator. They give it to you on the exam day, right? It's a very simplistic, simple calculator. It's not your text instrument stuff, but just plug it in one by one. As painful as it is, it's a guaranteed free question on USMLE, which is worth the time.
Excellent.
Good job, guys.
Excellent. Thank you, Abraham. Great work, everybody. I am really hopeful that everybody is walking away from Question Lab with 1, 2, 3, maybe 5 pearls that you can apply to your studies and keep in mind as you are heading through the world of biostats. So great work, everybody. Now I have the QIDs that we used for tonight's session. And what I'm going to do as well is I'm going to go in and I'm going to actually share the link to the test in the chat here. So give me just 1 second. I meant to do this earlier, but it's a beautiful day here in St. Louis, so I was out walking a little bit longer than I should have. Okay, so here is put it in the chat. So if you've got RX 360 Plus or QMax, you can check this out. So again, the nice thing is that we've got full explanations for all of these questions. Plus, we have links to relevant bricks, relevant express videos, flashcards, you name it. So again, if you want to reinforce some of the concepts that we've covered here tonight, please do that. Okay, so again, plenty of ways that you can follow us. We're on Facebook. We've got the blog at firstaidteam.com. We also have a blog on the USMLE-Rx page. We've got flash facts that we send out on Twitter and Blue Sky. Instagram always has questions and great information. We're on Threads, we're on TikTok, we're on YouTube, and YouTube is where you will find the recording of tonight's session.